Hi, I'm Sabir again. In this tutorial, I'm going to discuss all about the differential stresses, which is a great role, especially in faulting and rupturing in mechanical engineering and in even geological engineering, especially structural geology. So this tutorial is all about differential stresses. Differential stress or differential stress, yeah. So from the principal stress tensor, we know there is a if this is a principal stress tensor zero for three-dimensional cases. So 0, sigma 2, 0, 0, 0, and sigma 3. If this is a principal stress tensor, in geology or in civil engineering prospects, geology geology and civil engineering prospect, sigma 1 is termed as the greatest compressive stress, and sigma 3 is termed as weakest compressive stress. So I'm going to change the color and write down. So sigma 1 in geology and civil engineering perspective, sigma 1 is the greatest compressive stress. That means the maximum principal stress. Maximum principal GRE or the greatest compressive stress. GRE greatest greatest compressive stress. And sigma 3 is denoted as minimum principal stress. Minimum principal stress or weakest compressive stress. Weakest compressive stress, right? But in other engineering and other engineering and physics, sigma 1 is called the other engineering or other physics field. Sigma 3 is called the greatest, and sigma 1 is called weakest. That means the vice versa. So in geology and civil engineering case, it is sigma 1 is the maximum principal stress, and sigma 3 is the minimum principal stress. So for example, we can calculate the maximum. We have already know how to calculate the principal stresses and principal stresses and principal stresses, right? So for example, I gave you an example. I gave you an example, say um, minus stress tensor here minus 10, 15, minus 25. That is 15, 20, and minus 35, minus 25, minus 35, and minus 30. So this is stress tensor, and from there we have already calculated. In the previous lecture, we have already calculated the principal stress. What are the principal stress? Sigma 1 is, or alpha 1, or alpha 1 is 48, 48.8867, right? And alpha sigma 2 or alpha 2 is equal to minus 14, minus 14.6016, and sigma 3 for lambda 3, sorry, yeah, it is, sorry, I'm saying it is alpha, it's not alpha, it's lambda. Lambda 3 is equal to minus 54.2852. So here this value is the greatest compressive stress or maximum compressive stress, sigma 1, and sigma 3 is the minimum compressive stress or the weakest compressive stress, sigma 3. And what is sigma 2 then? Sigma 2 is the intermediate stress, intermediate principal stress. So it has also role, especially in faulting or fracture developing or something like that. So difference between the greatest compressive stress and the weakest compressive stress is called the differential stress. So we denote differential stress as sigma d. D is the differential stress is sigma 1 minus sigma 3. So however you write, or sigma d equal to sigma 3 minus sigma 1, or sigma 1 or something like that. So so this is also called so sigma 1. So this is this equation for other than civil engineering on geological department or something like that, but it's also geology and civil engineering perspective. So this is called differential stress. Here double F E R E N differential stress. Yeah, it's a maximum shear stress. So what is the maximum shear stress? So so what does the differential stress mean? Differential stress mean the variation, that means the standard deviation, the deviation between maximum and minimum. So from there we can really identify that if the differential stress is mass, then the faulting or the fracture development or something like that is would be in greater way rather than if there is a great differential stress is low, because the stress difference is minimum and maximum stress difference is so high. Okay, so we have another term, maximum shear stress. Maximum shear stress is nothing. Maximum shear stress is sigma 1 plus sigma 3 divided by 2. This is the maximum shear stress. If I'm not wrong, yeah, I'm going to see. Yes, quantum mechanics. What is that? Yeah, sorry. It is the maximum minus minimum divided by 2 is the maximum shear stress. Yeah, so this should be the maximum minus minimum divided by 2. So sigma 1 minus sigma 3 divided by 2, or sigma 3 minus sigma 1 divided by 2 is the maximum shear stress. Maximum shear stress has great role, especially in geodynamical, geological, or structural geological perspective. So we say it's maximum shear stress. Thank you very much for being with us. Don't forget to subscribe to Sabit Foundation, because Sabit Foundation is dedicated only for scientific lectures and scientific research. Thank you very much, and I'm going to see you on the next lecture.